Welcome, everyone. We're just waiting for a few more people to join us before we get started with this webinar. All right. I think we can get started. So first of all, welcome everyone. My name is Elizabeth. I am Product Marketing Manager here at Vention, and I'm thrilled to be hosting our first automation tips webinar on robot path programming. So please note that this session is being recorded and that all participants have been muted. You will receive an email after this session with a link to the recording, as well as any unanswered questions. But right before we jump in to the presentation, here are just a few best practices to keep in mind. The presentation will last about 35 minutes and we'll have a quick Q&A period at the end. If you have any questions, you can add them to the Q&A section of the Zoom platform at any time during the presentation. And please feel free to chat with other participants in the chat section. With that, I'm happy to introduce you to my colleague, Jeremy Andrews, who will be leading this presentation.
All right, thank you, Elizabeth. So as she said, my name is Jeremy Andrews, and my role here at Vention as application specialist, in short, is to assist clients by creating designs to meet their automation needs. So from here, I'll just go over a few of the key points and the key learnings for this webinar. So ideally for this webinar, you guys will learn how to first create a robot path sequence using MachineLogic's newest MachineApp, robot path programming. Second, be able to simulate your robot sequence in real time using Machine Builder. Third, be able to push your program from Machine Builder to your specific robot. And finally, be able to run your program on your deployed Vention robotic solution. From here, I'm actually going to transition over to our website to give a brief overview of the basics of MachineLogic. So first off, MachineLogic is at its core a code-free way to program your automated solutions. So this includes, but is not limited to, linear actuators, conveyors, pneumatics, and much more. If you're interested in seeing a bit more in-depth explanation of MachineLogic and its capabilities, I do invite you to revisit any of our previous webinars, which are housed in our resource section on our website, as well as our Vention YouTube channel. Since today, we will be highlighting more specifically the newest edition of MachineLogic robot path programming. So in short, what does robot path programming allow you to do? It allows you to program your robot in the cloud and deploy to your shop floor with a simple calibration step. The robots that are currently compatible with this are first the FANUC CRX and the CRX 10iAL, which are the newest line of collaborative robots from FANUC. Secondly, the Doosan H-series robots. And finally, the Universal series robots, both the E and the CB series. One of the greatest features of the robot path programming is that it is completely free to simulate and no purchase is required to actually do this within the cloud. All it's required is an account on Vention's platform. From here, I'm actually going to jump into the design that I will be showcasing for the rest of the webinar. For this, I will be showcasing a machine tending cart application with one of our robots that do function with this program. The first thing that is required to get started for robot path programming is to enable the MachineLogic tab. Initially, there are two different ways to do that. First is to actually add a machine motion controller or add a robot that does function with the path programming. In our case, we have already added the robots, but just to reiterate the ones that you can use are first the FANUC CRX models, the Doosan H-series models, and finally, the UR model that you see on screen here. This is the one that I'm going to be using for the rest of this. First, again, you have to configure it. So configuration takes part in two sections. The first is the hardware, and second is the software. The first portion of the hardware is actually to add a robot itself. In this case, I've already done this, but after doing this, you do have to add the robot calibration tool. So in the robotics section, we have the robot calibration flange. I'll touch a bit more on this later on in the webinar. From here, you do have to select your end of arm tool. So going back to the parts library, I'll select the robot end of arm tools. In this case, since I will be doing a live portion later, I'm going to select the end of arm tool that I've used in real life. So this is going to be an on robot gripper. So first thing that I do is select the on robot tool changer and snap it to the end of arm. From here, I can select the one that I'd like to use, which is the 3-finger gripper, and select auto complete. With this, it does configure and allow you to add the appropriate hardware for your robot. From here, this does terminate the hardware portion of the calibration or the configuration. The second thing that you have to do is configure it is the software configuration. So going to the MachineLogic tab, which has opened up since I've added my robot to the design. So from here, it does give you some tips on what to do to get started. So you can first either click Add Actuator, which in this case is not the case since we are going with robots, or Add Robot. So in the bottom left-hand corner, I'm going to select Add Robot. From here, you do have the option to select from a drop-down menu if you do have multiple robots in your design. One thing to note is you can only program one robot at a time in the design. In this case, I will select the robot model of the UR5E. Quick loading here is really just to connect to the servers dedicated to the robot path programming simulation. Once this has loaded up, I can actually rename my robot. In this case, I'll name it UR5E and select the end of arm tool from the drop-down menu. In this case, I have the on-robot 3-finger gripper. Notice here you have the pinout options. So these will be used to actuate the end of arm tool in real life based on the output pins configured and wired to your robot controller. So from here, we have essentially finished the configuration step of the setup. So this is, again, just to reiterate, pardon me, the hardware section and the software section. From here, we actually can get into the programming. So very similar to MachineLogic, if you are versed in this a little bit, we have copied over much of the same functionalities since the robot path programming is a subset of MachineLogic. In order to get started, all you have to do is add application. So you do have two options over here for robot path programming. First being adding machine tending or to add a custom application. In our case, we'll be doing a custom application. From here, you can actually rename it. In this case, I'm going to rename it pick and place, which will be the type of application that I will be programming for you guys today. Similar to your standard MachineLogic programming, the way that it functions is that your sequences and the program that you create are housed either within a main sequence or a child sequence. Essentially, the main sequence is where you assemble and run your program. The child sequences are the individual actions that are called within the main sequence. Very similar to standard programming, where you have your main script and the functions that you call within your script. Child sequences act as the functions, and your main sequence is the primary script within this. From here, there are two separate locations that you can actually create your robot path. First is in the main or the child sequences. So this is in the actual programming area. And what this does is it creates a local sequence. A local sequence is meant for one-time use actions. The second location that you can create a robot path is in the robot assets sections under robot paths. What this does is create a global sequence. So this is similar to variables that was covered in a previous webinar, but essentially what a global path allows you to do is allow you to call it at any point throughout your program. If this is a little unclear, this will be kind of elaborated on later on. So from here, we're actually going to get started with creating our first robot sequence. First thing that is recommended to do is create a child sequence. In my case, I did already create one, but I can actually restart that. So I'll delete it. The bottom here, you have the option to add sequence. In this case, it will then repopulate with the name child sequence. In this case, I'm going to rename it pick 1, since I'm going to be picking from a primary location. From here, I have the option to add command. So clicking this, you do see that there are 3 options to choose from. The first being add a robot path, which is what we're going to choose. Second, add robot loop, which will come into play later on during the webinar. And finally, add execution, which is the similar function from our standard MachineLogic library. So I can select add a robot path, and this is what does populate. So I can rename the robot path that I like as, again, I'll name it pick 1 or pick. I can select from the robots that I have. In this case, I have only the UR5E, so I'll select the UR5E. I'll cover a bit of the information on screen here before I actually get to the programming itself. So the first thing to note is the local reference frame. So essentially, your reference frame, in short, is a frame of reference used when creating or teaching the points that you'd like your robot to travel to. Or another way to say this, so all points being taught are in relation to this base coordinate. So your local reference frame is the base coordinate, which can be thought of as your 0 point, say, on a graph. In this case, I am going to move my local reference frame to my initial picking location, which will be this part over here. Initially, the local reference frame, or any reference frame generated when creating new robot path, does start at the base of your robot. From here, we have the option to either add a waypoint. So waypoints are the point in space in which you'd like your tool center point or your robot to travel to, and the ability to add a command. I'll touch on a little bit more in terms of what the options are for adding robot commands as we go. So from here, I'm actually going to start off by building the robot sequence. Essentially, what I'm going to do is have the ability to have the robot pick up a part over here and place it in a secondary location. So to start off, I will start by clicking Add Waypoint. So with this, you do have 3 different ways to select the robot position or create the waypoint. The first one being point to point. So this is a functionality that does carry over from the standard machine builder in terms of attaching parts together. So essentially, it snaps the tool center point to the point that you would like to travel to. Once you are happy with your location, you can select Confirm Waypoint. If for whatever reason you did move the robot to a location that is not intended, you are not kind of set in stone with that location. You do have the ability to actually edit it. So in this case, I'm going to click Edit and use the second option for moving or creating a waypoint. And this is the triad. So from here, I can actually use the triad to drag my robot to a different location. So this can either include moving in a specific axis, a plane, or around a degree of freedom. Once I'm happy with this, I will confirm my waypoint. From here, I'm actually going to add a robot command. So one thing that I like to do for is pick up this part. First thing that I like to ensure is that my gripper is actually open for this action. So I'm going to add a robot command. And from here, I do have 3 different options. First being gripper open and close. Second being wait for amount of time. And third, wait for a digital input. In this case, I want to make sure my gripper is open. So I'll select gripper open and close. And from the drop-down menu, select open. From here, I am going to add one more robot command just to wait for half a second or 500 milliseconds to ensure that the gripper is open prior to going down to pick up my part. From here, I can actually add my secondary waypoint. I'm going to continue with the point to point just to ensure that I'm going to the exact location that I would like. Once I confirm, click confirm, and I'll continue building up my sequence from here. In this case, I'm going to use the triad again. Once it does bring down to its specific location, one thing that you actually have to do is pick up the part. Again, so once you see I added a waypoint, but what I actually intended to do was add a robot command. So in this case, I can delete the waypoint without actually editing anything else within my sequence. So once I am back down to my pick location, I will add a robot command to actually close the gripper. To ensure that I'd have enough time for the gripper to close on the part, I'll add one more robot command to wait for a set amount of time of, let's say, 2000 milliseconds or 2 seconds to give it enough time to actually close. From here, I'll add one more waypoint. Once I've grabbed my part, I'll move the robot up out of the way and confirm. From here, I will actually show you the third and final way to edit the waypoint, and this is with the jogger. So from the drop-down menu, if you select jogger, you do have this window that appears over here. From here, you can actually edit the position with relative to the design space by inputting a number, or by manipulating each of the joints using the joggers over here. So in this case, I can edit the shoulder to move it up a little bit, just to show you how it's done. Once confirmed, I can close the window and confirm the waypoint. From here, I'm just going to build out the rest of the application to drop off at the secondary location. So add point to point, move to the location, and just bring it up to ensure that it is hovering over the correct area. Confirm waypoint. So I could go directly from top right down to the drop position, but I don't want to do this just to make sure that the part does not interfere with the part presenter plate itself. Add one more waypoint, point to point, snap down to the location of the drop-off, confirm, and finally add a command to open the gripper to let go of the part. Again, I will add a wait time. In this case, again, 2 seconds just for safety. And finally, add a final waypoint to get it out of the way. Once I have confirmed my waypoint, I can actually go through and click each of the individual actions to ensure that my robot is following the path that I would like. One thing to note is I did brush over a few things that are present in each of the waypoints. I'll touch on those now before I actually build my sequence. First thing that you'll see on the right side is the option to either click or unclick or select use joint angles. So essentially what use joint angles means is it ensures that the robot ends up in this exact configuration shown in CAD. So for example, at the specific waypoint, if I click use joint angles, it will make sure that my robot does end up with the joints in this specific configuration. If this is not highlighted, all of the robot really cares about is to ensure that the end of arm tool ends up in this location. The joints can be reversed as long as the tool is in this orientation. A second thing to note is the path type. So you do have two different path types while creating your sequence. The first being move L. Essentially, move L ensures that the robot moves the tool or the tool center point from one waypoint to another in a linear path. If you'd like to see this, you can actually click on the question mark over here, and it does give a definition as well as a short animation to highlight this action. So again, move L moves the tool center point in a linear path from one point to another. The other option that you can do is move J. Essentially, move J ensures that the robot ends at the specific location, so moves from one waypoint to another, but it can travel in a curved path and does not necessarily have to be linear. So in this case, if I have to move J and press the highlighted help button, it does show an animation of the robot moving from one point to another, but you'll notice that the tool point does move in a curved manner in some ways. So once I'm happy with the program that I have built, I can actually go to my main sequence and build the program itself over the path. So in this case, I will add a command. I already have the robot path created. Essentially what I have to do is actually call it. So I'll go down here and add execution. Essentially, you do have the only option to execute in series since the robot can only do one action at a time. From here, if I only have one child sequence, you'll only have one option, but later on, I'll show that there are multiple options you can select from. If I'm happy, I can press play, and the robot will move in real time within the machine builder with the program sequence that I have done.
So let's take this time to answer a quick client question. So Jeremy, the question is, for editing the robots while using the triad option, are you able to move individual joints of the robot as well?
Yeah, so that's actually a great question. So let's see over here. So yes, in fact, you are able to actually manipulate the joints as well. So you'll notice over here, we have the triad, which I highlighted earlier, that allows you to move in a plane, in an axis, or around a point. You'll notice at the joints, you also have the option to rotate around there as well. So clicking on these separate joints does allow me to rotate those. Once I'm happy with that configuration, I can also click confirm. So that is a great question. And again, if there are any other, we'll try to answer them throughout the webinar as well. So from here, we're actually going to move on to global sequences. So just to reiterate a bit, so global sequences are mainly used if you have a process that repeats itself multiple times, but at different locations. For example, if I zoom in over here, you notice they have multiple parts on the part placement over here. In the next sequence, what I would like to do is pick first the first location, drop off, and then pick up at the second location and drop off. As opposed to rebuilding this entire sequence that I've just done, what I can actually do is over here in the top right of the robot path that I've created is save it to my robot assets. Once clicking that, notice that it does lock the sequence in play and does not allow me to edit it. In order to edit it, I have to go to the robot assets and edit it from here. So in this case, you can see that the the reference frame over here has changed from local reference frame to global reference frame. So essentially, each time this sequence is called throughout my program, it will start off with the reference frame that I've selected. In this case, since I did copy it over from my initial program, it keeps with the frame of reference that I've created over here at the base of the first part. For the purpose of this webinar, I will leave it where it is. One thing to note is, although I can edit the robot path program over here, I cannot actually delete it. One of the reasons being is that it is being called upon in the program. In order to erase it, I do have to delete the areas which it is being called from. So in this case, I'll show you how to actually use the global sequence. So I'll go back to my standard application and add an extra sequence. From here, I'm going to call it pick 2. So essentially the second location that I'd like to pick from. From here, I will add a robot command and add a robot path. You notice that it will initially start off by populating with the global sequence that I've already created. From here, I can either chain to create a new sequence, and build it from the ground up, or keep with the original robot path that I have created. From here, the only thing that I really need to change is the local frame of reference. So you'll see if I do play this, it will try to pick up from the same location since it's referencing this initial point. If I edit this, I am able to change it to pick up from the second location over here. From here, I can actually go back to my main sequence and rebuild my program. Just to show you how easy it's done, I'll actually delete the initial portion over here, go down to add command, add execution, and from here, I do have the option to select from the sequences named either pick 1 or pick 2. In this case, I'll leave pick 1, add a second execution, and select pick 2. So from here, if I zoom out, go back to my main sequence and press play, it should first pick up from the first pick location, drop off in the first drop off location, and then start again from the secondary location. So from here, I'll press play and you can see this in action. So first, you'll notice that it does highlight in green the sequence being called. As it finishes with the first one, it'll highlight the second one, and you'll notice that it did go to the second pick location since I've changed its reference frame. From here, I'll be touching on one of the other additions to robot path programming, which is robot arrays. So essentially, robot arrays are useful for repetitive motions, similar to what I just did, but with different starting points for each set of moves. Again, this is very similar to what I just did. However, what makes robot arrays special is that you can actually create a grid pattern rather than having to create a child sequence for each pick position. So again, if you'd like to learn a little bit more about what robot arrays are, you can select the help button over here and get a good definition as well as an image to showcase what the definition is describing. So in this case, in order to start it, I will click add a robot array. And then the first thing that I have to do is select my frame of reference that I would like to start. This will usually be the first position that you will be starting your sequence from. So in this case, again, I'll start at the first place. Robot array, I will select fixed spacing. And I can rename the robot array if I would like. Again, this is useful if you have multiple arrays, but for the purpose of this webinar, I'm going to stick with just the single one and keep its name as a robot array. In our case, we're going to have 2 rows and 2 columns. The reason being is I'd like to have 1, 2, 3, 4 pick locations. So with this, I have that. And then create the spacing between these. So in my case, I do already know the spacing, so I can simply input it over here. With this, I can click generate array, and you'll see that it generates the points around the 4 locations that I previously described. From here, you do have the option to actually reorder the picking order. So in this case, it will first pick from the reference frame, then go to 1, 2, and 3. Again, to reorder those, you can simply drag and drop. But if I'm comfortable with this, I can select done to confirm my robot array. Going back to main sequence, I can actually delete the other sequence that I have built and build up my new program. You'll notice that I did not actually have to delete the child sequence, and I can actually have as many child sequences as I'd like. As long as I don't call them within the main sequence, they will not have an effect on my final program. So in this case, I will add command and add a robot loop. So this is where the robot loops come into play when you have an array. So this jumps from one point to another. So in this case, I have the drop down to select robot array. In this case, I only have one. And then I can choose either the sequence to play. Since both pick 1 and pick 2 are the exact same, it really doesn't matter which one I choose. But once I've done that, confirm that I like my program, I can press play. One thing you'll notice, it will loop starting at the first and then go through the other options. On the left, you'll see the actual action being executed as it highlights it throughout the pick.
We actually have another question from the audience. So Jeremy, what end-of-arm tools are supported with this new software?
All right, so just to reiterate, so that's what end-of-arm tools are supported with the new software. So it's actually a great question, and in order to answer that, it's essentially all end-of-arm tools that are currently on Vention's platform. So if you're curious to see which ones are supported, you can actually go to the machine builder section, and you will notice the robot program will continue to play. At this point, it just did terminate its action, but had I switched earlier, it will continue to play as I switch over. So in your parts library, you can go to robot end-of-arm tools, and any of the end-of-arm tools that you see here, say some of the on-robot grippers, the shunt electric and shunt pneumatic ones, as well as some of our vacuum grippers from other partners, will actually work with this robot path programming. So hopefully that does answer your question. If you'd like a bit more elaboration, we can either touch on that later or answer it in an email that does get sent out to everyone at the end of the webinar. So going back to the actual programming itself. So one of the final things I'd like to touch on the cloud section is the calibration tool. So earlier I did add this calibration flange to the end of robot. There is a part that does go with this, and it is the calibration tool that you see over here highlighted in green. In order to go to that section within MachineLogic, you select Robot Assets and go to Digital Calibration Tool. Again, if you'd like some more information, you can select the Help button. Really, what the calibration tool allows you to do is to accurately deploy your machine from the cloud to factory floor. So this does kind of calibrate to match your cloud design that you have over here to your live deployed Vention product. One thing to note when placing it in design, and the design itself, is to ensure that the cloud placement mirrors its physical counterpart exactly or as close as possible. This will allow the deployment and live calibration of the robot to proceed as efficiently and effortlessly as possible. For machine tending setups, it is recommended to have multiple calibration tool for each pick plane or pick location that you have. So in this case, say I have 1, 2, 3 different drawers, it is recommended to have at least 3 calibration tools or 1 calibration tool per picking plane. From here, I did show you how to program one of the robots on the cloud section. And from here, I'll show you how easy it is to actually deploy to your Vention machine. Once you are happy with your sequence and your program that you've created, all you have to do is go to the bottom left corner and click upload/download. So you do have the option to upload application. This is usually after you've already downloaded it and would like to say edit it itself. So you upload the program again, edit it, and then re-download. In our case, we will select download application. One thing to note is that this button is only accessible once you have actually created your path program and purchased the design. So the script, also one thing to note, is the script is specific to the robot used in this design. So there's no need for any external hardware other than the robot, the controller, and the pendant itself. Just to elaborate on that, in this case, I have the UR robot, so it does download a script that works with the UR. If, say, I had a FANUC robot in here, it would download a script that functions with the FANUC controller. So from here, we'll actually be switching over to the live portion of the webinar to show you how easy it is to deploy your section, your program that you've just created. So in this case, I will switch over my camera to showcase pendant and stop sharing my screen to give you a full view. So what my colleague will do is assist with actually, the robot is already, the program has been downloaded, and simply select it from the menu. And from there, you can see the script on the left side that does showcase what I created in the cloud version that I just showed. From here, we'll actually press play and you can see the robot move in real time. So from here, you see the robot does pick up from its initial pick position. And you can note that this design does mirror exactly what we have shown in cloud. One thing to note, say as the robot is going and you notice you'd like to edit some of the path, it's as easy as opening up Machine Builder that I demoed earlier, modifying any actions that is required that require edits within it, downloading it and redeploying it to your machine. So as I showed earlier, all you have to do is plug in the USB, select the program that you would like to play. There is a calibration step. In this case, we did do it prior to the webinar, but it usually takes about 2 minutes to do, and simply press play on your machine. And if fully calibrated and set up correctly, it's as easy to play as seen before. So really this does show how easy it is to create a program within MachineLogic and deploy it to your live Vention deployed machine. So from here, I will just give a brief summary of the topics covered before we move on to the question and answer period. So the first thing I like to highlight and things that were shown are primarily first the waypoints, which are the points in space that you would like your robot to travel to. Second, the robot commands, which are threefold. You have the robot loop, the ability to add a robot path, and the ability to essentially execute one of those paths that you've created. After that, we have the robot reference frames, which are the reference frames used when creating your path. The ability to calibrate your robot both on the cloud and the live portion, and shown how easy it is to actually deploy your robot solution or your robot path program created in MachineLogic. And one thing to note, for anything that you may have missed in this webinar, it is covered and will be sent out as a recording, but there is a section on our website under resources where you can find documentation, both in terms of written form and videos to show everything that I've done today. From here, we will actually be moving on to the Q&A period if there are any questions asked by the audience throughout the presentation. And let's go back over here and share the demo in case there are any questions that pop up about the application itself. So one of the first questions that we have is about the arrays, actually. So we have the question here. So is there a maximum number of points that you can generate in an array? So this is a great question, and there is actually an answer to this. So if I go to robot assets, show the robot array. Oh, let me actually realize I was not sharing. Yeah, I'm sharing the correct screen. So in robot assets and robot arrays, if I'd like to edit it, you can actually edit the rows, but there is a maximum of 10 rows and 10 columns. So if you actually do the math of this, it does give you a total of 100 different pick locations. For the moment, we did think this was sufficient for the initial release of robot path programming. So we do have a question as well. So when you added the on-robot tool, did it automatically set the tool center point? So yeah, so as you saw, I did add the on-robot tool using the automatic configurator. And as soon as you attach the end of arm tool to the robot, it does automatically offset the tool center point. So this does tie in with the question earlier about the number or the possible end of arm tools that do fit with robot path programming. All of those end of arm tools already have the tool center point already pre-programmed and set to automatically offset. Let's see if we have any other questions. Yeah, so we have one over here. So it mentioned that in order to download the program, you have to have purchased the design. Does this mean that we can also get the robot arms from Vention as well? So yeah, so this is actually a great question. So yes, you can in fact purchase robots directly through Vention's platform. And the ones that we do offer, so if I go back to Machine Builder, in the parts library and the robots, the ones that we do offer that you can purchase directly from us that function with the robot path programming, again, are the FANUC CRX. So these are the collaborative models recently released by FANUC, as well as the Doosan H series. And we have one more question, I believe from here, we can, after this question, if there are no any other ones, we can end it, but can you reorder the waypoints once they have been created? So going back to MachineLogic tab into the visual sequence and robot assets just to showcase this. So currently you are limited to editing, you are only limited to editing the waypoint itself. However, this is a feature that we do in fact plan on adding in the future. So for example, say for a waypoint, you did maybe move it to location that was not intended. So right now, in order to fix this, you can actually press edit and move it to the correct location. After this, are there any more questions? It seems, oh, we do have one last one that I'll cover. And then from here, I can pass it back to Elizabeth. So do I need a digital calibration tool to run the program? So as mentioned earlier, the digital calibration tool is helpful for calibrating and really deploying your Vention product in real life. However, it is not necessary for deployment. One thing to note that it is recommended for higher accuracy picks, as well as scenarios where you have, say, like multiple planes as this. Or another example that I mentioned earlier is if you have 3 different pick locations around the robot, it is recommended to have a calibration tool at each of those points. Let's see. So from here, I believe this does end the questions that we have at the moment. Any questions that I did not answer, we will answer in the email if possible. So from here, I will actually pass the microphone back off to my colleague, Elizabeth, for the closing remarks.
Thank you, Jeremy. That wraps up our Automation Tips webinar. Thank you so much for joining us today. We are very much looking forward to seeing what you'll do with this new exciting tool. And as mentioned, we will send you everything in an email following this session. And also, please keep in mind what Jeremy said. You can find all of our resources in our resource center on our website or on our YouTube channel. So please keep us posted on what's next for you. Enjoy the rest of your day. Thank you.
Have a good one, everyone.